Okay, so here is the check for understanding on the popsicle stick lesson up here. We just did this. Um, so this question is about World War II. As the Allies captured German tanks, they were trying to determine how many tanks the Germans had, um, so that they could plan. Um, and they were capturing the tanks and looking at their serial numbers, um, trying to figure out how many tanks were out there. Okay. They have three different sampling methods, one, two, and three, and they each have these distributions. They all look different. Um, they always used a sample size of 7. So, like this dot here would be the estimate that came from a sample of 7 tanks. This also would be 7 tanks. The taller bars would have multiple samples of size 7 at those locations. Um, so the red lines represent the means of each statistic. So you can see there's a red line right on top of the blue line there. So for this distribution, the mean was right here. For statistic 2, the mean was right here. And for statistic 3, the mean was here. The blue line down the middle of the whole thing actually represents the blue line marks the total number of German tanks. So this is the parameter right here. Okay, this is the parameter n, um, and the red line is the statistic. So red, red, red. Question number 1 is: do any of these statistics appear to be unbiased? Well, a statistic is unbiased if it accurately reflects the parameter. So that happened right here and right here, where the blue line and the red line are right on top of each other. So both 1 and 3 appear to be unbiased because the mean of the sample distribution is very, very close to the blue line, which is n, the number of German tanks. Statistic 2 appears to be biased because it is overestimating the number of tanks. So maybe, I don't know, let's say this was 200, but in reality there's only 150 or something like that. It's overestimating it. Um, it's clearly greater than what it's supposed to be. Which of these statistics is best? Well, we can clearly rule out this one because it's overestimating, so it's now number 2. You can make a pretty good argument for, I guess the argument for statistic 1 is that it kind of looks normally distributed. But normally distributed isn't always the best. So what I've written here is statistic 3 is actually less variable than statistic 1. If you quantify this, for example, let's say down here was 100 tanks and way up here was, let me get rid of these numbers for a moment. Let's say way up here was 200, and then what we're looking for is, I don't know, say 140, okay? And maybe this mark here is 150, okay? The upper statistic is far more variable. It has a range of 100 to 200, so it has a range of 100. So that's a measurement of spread. While statistic 3 only has a range from 100 to 150, so it's much more consistent and less variable. So that would be one argument to do statistic 3. Number 3, how could you get more precise estimate for the number of German tanks? Well, over and over and over in this class, if you want to get better statistics, uh, you're going to hear it over and over. Increase the sample size, capture more tanks, okay? This way, the estimated number of tanks is more likely to be close to the true number of tanks. Also, when you take more data, the the curve, well, like up here, is like this. If you take more data, it is going to become tighter like this. The standard deviation will decrease, which will make your results more consistent. So summarize your work there, guys. And that's it for this check for understanding.